Welcome to this tutorial. Now, just before I begin to speak, before you get too confused about the leading page, which you can see here, which represents a specific appliance or device if you want to. This tutorial, however, is not going to represent anything specific at all. I just happen to have the diagram of a case which I just had going on, and I'm gonna use that case as an example in some of my explanations, as well as I'm just gonna use this diagram for explanation of overall phenomena you will find when you're trying or attempting to repair or diagnose vintage amplifier circuits and analog circuits in general. Now, if I scroll a little bit down here, we can just see the contents and which part of the world it was made, and we can see some of the values for different components, the typical stuff you will see, and yeah, the components list. Now, there are very bad graphics, unfortunately, in this diagram. I hope you can see the mouse though. But before I begin to explain anything at all contributing to the diagram, I'm just going to talk about the approach, your approach to be most likely to gain any success at all with, if you're gonna want success when you have little or no experience. Now, the problem I had when I began to work with electronics was that I always used to think about the most complicated things you will find in a circuit, and how in the world am I ever gonna be able to crack that nut, diagnose a bad chip, and so on and so on. That is a totally wrong mindset or approach when attempting to diagnose your problem, because in electronics there are sealed solid-state units. Even in some of the older electronics, you will find units which you cannot repair so easily, and you will just have to replace a whole part of the circuit in some cases where there are solid-state circuits. But generally, in these older radios and amplifiers, old TV sets, especially in old tube amplifiers, they are good to begin with because they don't have so many chips to it, and gates and voltage regulators, integrated rectifiers, and multi-transistor chips, stuff like that. They are pretty basic. If you attempt to repair an old amplifier from the 60s, tube amplifier, for a guitar for instance, probably the most advanced component you will find in there is a PNP or a MOSFET transistor. Now, it's a good idea to know how a transistor works and to know the difference between a PNP and an NPN, and of course to know the basic things like how a diode works and how to use Ohm's law, knowing how a capacitor behaves in direct current situations as well as alternating ones. Just knowing the basics about how these components work. Now when you look into transistors and their working, which is probably some of the most complicated basics, very basics, you're gonna run into something called transistor biasing. If you want, it's always a good idea to get a better understanding of that. However, it's not 100% necessary for trying to localize faults. Always. So, a few things I would like to explain. Where to begin when attempting to repair old or vintage devices such as radios and amplifiers. Now, anytime when we are looking for a signal, that may be a radio signal which is transmitted through an antenna somewhere and then received by a radio receiver that can be frequency or amplitude modulated. But when you have a device which can absorb that and process that radio signal, pre-amplified, filtered, etc., you have a device called an FM radio if it's frequency modulated, and if it's amplitude modulated. If you want to know what that means, you can just go look it up. But yeah, when you have a processor for that, you have the radio part of your unit. In the old stackable stereo systems, you used to have something called only an FM and AM tuner. Probably had long wave too, but that whole case was just a tuner, even though it was monstrous or enormous. It would have an antenna on it, so that it could absorb the potential signals coming into it, carried by a transmitter somewhere. And then you could tune it in, of course, like you would do with a normal FM radio. Or you could choose AM, and then you tune it in. And what you do when you tune in, you adjust the capacitor, the main variable capacitor. And whenever we're talking about a signal, we're talking about alternating current if we're talking about an analog signal, naturally generated and not rectified or semi-rectified. It's gonna be alternating current. And yeah, just to explain you a little bit about it, a capacitor will always block direct current. So if a capacitor is in the series of a direct current circuit, it's going to break the circuit. It's like an open circuit if a capacitor is in the series somewhere. However, alternating current can get by the capacitor, but depending upon conditions, it can block some frequencies and only allow some frequencies. That has to do with corresponding or coils, transformers in its context, or in the context of its uses. So the capacitors are calculated for the desired frequencies if we're dealing with alternating current. And for pulsating as well as pulsating direct alternating current, and as well as for pulsating direct currents. Now I'm not going to explain you how exactly an amplifier works and stuff like that, so I probably get too deep now. Sorry. Please hang on. How long have we captured? Can't see that here. Oh well. Now then. So what I like to do when I am about to localize a fault, of course there are chips and advanced circuits that even I can't diagnose, even in the older appliances at times. But what will I do? I will think about or evaluate what the cause of what the problem itself implies. Now what is it? Does the radio part of a integrated tuner amp, like this one, this is an amplifier with a tuner in it, or a tuner with an amplifier in it, however you want to put it. But what is the problem? Do we lack a radio signal and the amplifier works well with auxiliary input? Or is one channel blown? Does it power off but there's no sound at all? Now what is it? Of course you want to evaluate the beginning of your problem and what the problem actually is, if you want. Now for example, if I had a blown channel, let's say only the right channel was working, then I would be looking in the diagram after where the splits, there you have two inputs from the FM. If you have a stereo FM, you have two inputs from the small signal going into the amplifier circuit. Now, do you have both circuits? Whenever you are trying to find or localize faults like this, use an oscilloscope. You can get a real cheap one, digital oscilloscope. And what an oscilloscope is a device which can read voltage over time. That's not only momentary voltage like you would find in a normal voltmeter, in a multimeter. No, this is much more sophisticated. This is what's called an oscilloscope, has a two-dimensional graph where the y-axis represents voltage, and the x-axis represents time, as it usually does when talking about time in a two-dimensional function. Now then, where you would expect a signal, a varying signal, which of course is in the input of a radio. Now the reason that the tone out of the speaker isn't completely monotonous is because it's variable. It's variated. It's varied. And the way it's varied is by varying the frequency as well as the amplitude. When we're talking about sound changes, now don't get me wrong, amplitude modulation and AM and FM frequency modulation are types of modulating the signal when talking about radios, which is not exactly the same thing as the changes in a sound wave so that it doesn't sound with a monotonous tone all the time. If you put direct current to a speaker, it will just subtract itself and if it's too high, it'll destroy the speaker. If you put only some direct current to the speaker, which it actually can withstand, it will subtract itself against the magnet, and then because the coil gets live, and as soon as you break the circuit, it will retract to its original state. If you on the other hand put a constant alternating signal to your speaker with a constant frequency, it'll just be a constant monotonous tone. So guess what it would look like if you put an oscilloscope to a direct current voltage. The line with the baseline would just rise. So you could see, instead of having 0 volts, you would have, for instance, 3 volts, and it would be a straight line, which wouldn't drop again before you broke the circuit, and then you would have 0 volts again. So you would just rise the baseline. So you don't need to use oscilloscopes. Use the oscilloscope where you expect direct current. Now, where do you expect direct current, and where do you expect alternating current? Alternating currents are expected, as I talked about, where you have signals. That is the input signal from the, let's say, phonograph. That's the input signal from your auxiliary input, even if you use an iPhone. That's the input signal from the FM or AM part of your unit going to your amplifier circuit. These are all signals, and these come in 2 channels if you have stereo. They enter the amplifier in 2 channels, and they exit the amplifier circuit in 2 channels. There is no way that an amplifier can produce stereo. It must be sourced with stereo. Elsewise, it cannot relay a stereo signal to the speakers. Now then, when the signal has gone out of the amplifier or through the amplifier and has been amplified, it's still a signal. Yes, you would still expect a signal. At that point, you're expecting pulsating direct current and not alternating current. What that means is that at this time it's only gonna jump up from 0 and down to 0, and up from 0 and down to 0, instead of jumping up above 0 and below to negative voltage, and up above to positive voltage, and down again to negative voltage. It will never get negative, as it's eventually amplified, because that's just how an amplifier works. And when it gets out, it's amplified by many times. When all the amplifications are put together, all the pre-amplification as well as the main ones, several hundred times can it be amplified. And when it reaches the speakers, yes, it blasts. It's a high, then it's transformed to a lower voltage and a higher current, so they can run big speakers which have fairly low resistance. Units are grounded. direct current units are grounded. They usually use ground. The end of each circuit or intended circuit, what that means is where some part of the circuit ends or just leads to its final, it usually goes to ground. Now, if you hope you can follow my little mouse here. I don't know why I can't use a cursor. It's just a little cross. But this here, I'm shaking around it, is a symbol of ground. Now when you're looking for voltages with your test meter, just constantly have your black or negative lead hooked up to ground. Make sure you get a good ground. And then you measure. You measure on wherever you want to, according to the diagram. Unless of course you want to measure specific voltage drops across some components or something else. But one of the key factors I like to exploit when trying to repair is given voltages in the diagram. And the given voltages are always gonna be, unless they're on the primary side of the coil before they're rectified from your household socket. But when you get into your circuits, your given voltages are gonna be direct current, and those are whatever they imply to be in relation to ground. So that's why you want to have your negative probe on ground when you try to look for given voltages. Now you can see that here, where I have the mouse right here, and go down to this first transistor right here, you would expect 20 volts when your unit is on, and that should be about it. But of course, if this was for some specific channel or something, you would just have to make sure that the channel is put on in the front of the amplifier where your controls are. But if it's not 20 volts when you put your probe on there and you have your other probe on ground, there's probably going to be something wrong. Then you're going to look for the problem behind where you come to here. And that's, you know, you trace the source further back as the voltage doesn't never get to here in the first place. So you need to look somewhere further back to where it broke off. Where is the component which made that the 20 volts cannot reach this stage? And no, it's not going to be in front of here, because we're looking for voltage, and voltage can still be there if there's a break somewhere, but voltage can't reach this side if it's broken before. But if it's broken afterwards, it doesn't matter. I'll just give you a very simple tutorial right here. Now, here we have A, and here we have B. And let's rub a little bit of this out and take the pencil again and write a little case here and write a C for circuit. That C means circuit. So in there's going to be a little circuit. It can be made up of several components, but the most important thing here is just that it enters the circuit where the A is, where the input is, and it gets out of the circuit where the B is. So current will flow from A to B. And you will just put the positive terminal on A and the negative on B. And the negative is typically grounded, so we can just write a ground symbol here as well. Now there's going to be a flow, a current flow in the direction of the arrows. And if the circuit is broken, there is some component causing the circuit to be broken. There is some component that has broken and breaks the whole circuit. If it's a circuit that depends on if it's a circuit which completely depends on that component which has failed. Now if we take a look closer at the circuit here, let's just zoom in on it. Now this is just a closer look, and for the sake of simplicity I just made the whole circuit of only 4 resistors. Now if our service manual told us that we would expect 12 volts where the green spot is right here, under certain conditions, which we then would recreate, or under all conditions, and if there was 0 volts, were 0 volts, then I would know that the breakage would be behind this spot, further back towards the input. Because now, even though if there's a break anywhere at all there in this circuit, there's going to be no flow of current, because imagine that this was water and there's a break there, then no water is going to flow out of here. And imagine this is plugged, so there's a plug in there. If there's a break in electricity like this, you just imagine it's blocked. There's a plug in it and it can't flow further. And it can't flow at all, since it can't flow because ground or minus is the only way for it to go, and if it can't go, if it's unable to reach the minus, it can't go anywhere, so it's gonna block all the current flow. However, remember that voltage is not current, and it's not the same thing. Voltage is like electrical pressure, while current is like electrical flow. And if I measure where there should be 12 volts on the green spot right there, and there is nothing, there are 0 volts, then I know that there's a break behind or further back from that green spot. Because if the breakage was right here, which is ahead of the green spot, then sure enough there would be no flow, but the voltage would still be reaching to where that green spot is. There would still be potential, electrical potential, which also is voltage if you want. There would be electrical potential all the way to the break, to the break where this red dot is, where there wouldn't be any potential after that, since there's a break right here. So having 0 volts on this green spot implies that there is going to be a break somewhere further back, for example here, or even here, so that the voltage potential can never reach its intended spot. I hope that makes sense for you. And as I talked about, these given voltages here in a typical, you can see some voltages somewhere. You can try to zoom a little bit in, and you can see some voltages somewhere. For example, 38 volts down from the mouse here. Here are 38 volts. So you would measure direct current, because you would expect direct current wherever ground is included, and when you're in the circuitry. And if there weren't 38 volts, yes, go further back and look somewhere. Don't look ahead of this. Don't look further through ground. Look further to the source, to the input. Further that way. Further back. And see where, when you, for the first time, see something that looks like the intended voltage. And then go further forward to see where it disappears, where the fault is. Now, this probably looks a little bit confusing. Which way does the flow go? Just reckon that some of these are just in parallel, but the flow is, you can usually look at the transistors where the emitter or the collector is, that varies a bit. It goes further, and it harnesses its input to one terminal, and the base is always the flat side, and it goes out of the transistor, and where it goes further out of the transistor, it goes further somewhere further through ground, towards ground, I mean. So look for given voltages. Given voltages are gold worth on trying to localize or diagnose, localize faults or diagnose, that is. And if you expect a signal that has disappeared, well, let me show you something. If we go further down here, you can see AM and a big arrow where it goes. That must be where AM comes in and where it enters where it initially enters the amplifier circuit. So, since it's not amplified, you would not expect a large curve at all, but you would probably set your oscilloscope to your lowest setting and see if you could see anything like a wave, because if you didn't, it would tell you that you have no AM input. And if there's no AM input, the source for that fault is behind. It's somewhere further back, so you don't need to look at this. You don't need to look at this further spot where it enters if the AM signal has disappeared, because the problem is going to be further back if there's no curve going to be shown on the oscilloscope when you try this terminal where it says 2.2 volts where it enters, or that terminal 8 right there, which is the same wire basically. But this is a chip, this, I don't know what, honestly don't know what's actually standing right there, but it's Q and something like 3 HA1197. That's a chip. So how can you say if that's gone or not? Try to see how many of these given voltages on each pin are within spec, because you can find the internal schematic for that chip, for example, on the internet. And if you find that and compare that internal schematic for this chip to this case and see where you have the voltages in relation to ground, as I told you a moment ago, and see where you lack the voltages. And if it seems like you lack voltages on the chip's output and the voltages are okay on the chip's input, chances are great that the chip has failed, if you know what I mean. And these voltages are of course direct current, where you're going to look for signals and alternating current with the oscilloscope. You're going to look, that's what you're going to use when you're looking for the AM here, you see, because that's a frequency input. And when you look at the main amplifiers, their power source is going to be direct current. Direct current is showing you if there's voltage getting to the amplifier. That, you know, the amplification current is going to be provided or supplied in direct current. But the base signal is going to be a signal, of course, the signal you want to amplify. And that signal is going to be either alternating, or if it's already pre-amplified, it's going to be, yeah, you guessed it, pulsating direct current. So if you have your basic, let's look at an amplifier circuit. If we go further back and go look at the main amplifier. Now, probably went too far this time. Let me see. No, here we are. Here's Q1 STK, sorry, 0039, and if we look further back, there's another Q1 STK 0039. Now these are the two main amplifiers, one for each channel, right and left, respectively. Now we can see the terminals here, and we'll know what is output if we follow these wires. We can follow some of these wires directly to, if I go over here, you can try to follow me, and you can indirectly or directly follow them to the output speakers, speaker A and B. And you see where the inputs are. What's coming from the transistors are suspected to be inputs from these series hooked up transistors, which are basically small preamplifier circuits. So they're in series with each other. And some of these capacitors are just for biasing and filtering. Now I honestly don't know exactly what all the components are for in this setup. Not everyone. So if you get a good reading on your oscilloscope on the suspected input, which is around right here from these transistors, and if you look further up right here, we should see constant voltages. I mean, to this terminal 2, I hope you can see the mouse, but to this terminal 2 here, which provides the main amplifier with power, where we should see a constant good number of direct current voltage. I mean direct voltage. You can trace this wire further back, and I know that this is going to be constant direct current, which you should expect on here. And if that's okay, and you read with your oscilloscope on here, and you get a signal in, but you get nothing. No signal or voltage out at all. You can almost say for 100% that your amplifier is gone. But if you have no sound at all, there's probably not going to be something wrong with your amplifier. Because if there's something wrong with your amplifier, the amplifier is split in two channels, as I talked about. You have an input channel and you have an out. I'm sorry. You have a right channel and you have a left channel. So if there's something wrong with your amplifier, it will usually only affect one side, depending on how it's set up, of course. But in most cases, it's set up that way that if something goes wrong and breaks the circuit of the amplifier, well, you're only going to lose one channel, and then you're going to then you have the great opportunity to compare that channel to the other one. As you can see here, you can't see the big picture because it's split in the it's cut in the paper, but you can see that here is something which looks like a mirror image of the two scenarios, and that's exactly what you thought, because these are equivalent circuits. They're totally equal, but one for each channel. They're eternally split in terms of input and outputs. So, as I said, I like to search for given voltages with your normal multi-volt meter and look for signals with your oscilloscope. Now you know where you should expect signals and where you should expect constant direct current voltages, constant direct voltages, as I have hopefully explained well enough. So if you're thinking, where the hell do I find this very component on my, if you're gonna look for a certain component, where the hell am I gonna find it? On my circuit board, which doesn't look anything like this diagram. Well, then almost every diagram has a schematic of the circuit board itself, which is gonna have the name of the component as well, so you can compare the name of your component on this, which is a schematic of your circuit board, and it still has the name on it. So you can compare the name of the component on your schematic of the circuit board to the name of the component on the schematic diagram, electronic diagram. So it can be time consuming and frustrating, but it does work. It's a good idea to print both of these it's a good idea to print both versions out, both the schematic diagram and the schematic of your circuit board if you're gonna work for hours. It can be a lot less frustrating. You can have such a much greater overview at your whole situation. I had a problem with this particular amplifier of mine, where there was no sound whatsoever. The main relay clicked, there was voltage going into the amplifier, direct current, but there was no signal coming into the amplifier, and I was lacking a lot of signals, bass signals. It turned out that this transistor here has failed, the most upper one you can see. So I had not 10.0 volts on this side, I had 0 volts, while I still had 30 volts on the input. 30 volts on the input, but nothing on the output, and the base had its 14.2 in intended voltage. So that would almost guarantee me that the transistor had failed, since there was no output. And sure enough, I desoldered the transistor and tested it with a diode test. If you want to know how that's performed, just go look for how to test a transistor with a test meter, with a multimeter. It's very easily done, but it requires to remove the transistor, of course, so it won't be misleading going through other components. So given voltages are fantastic when you're trying to localize a fault. They're the best aid you can get from schematic diagram, in my opinion. So as a conclusion to what I've just explained, look for the easiest and most obvious things first. A visual inspection of all the soldering joints. Do you have a blown joint, or does the circuit board has some capacitor leaked, or has flux from the solder deteriorated the material of your circuit board? Have the current carriers broken or deformed so badly that they could have broke? Do you have open soldering joints, blown ones. Is there anything visual which could be wrong? Go look further at that, and of course you could just repair tender and suspicious spots. You may have your unit working again. And of course you always want to look for all fuses if they are blown before you do any further investigation. And instead of doing what I did, instead of thinking about the most complex part of your circuit, how could I ever repair this? Begin where it's easiest. Have a logical approach. Does it get feed? Does it get fed? Do we have the expected inputs? If not, we're not going to have the outputs. A plus B is equal to C. And if we lack C, I mean if we lack B, we're not going to have the C. So we need to look for all the inputs, both the direct current ones, constants, and the signals, which are the sounds, basically. And where do they disappear? First, of course, we're going to look at the speaker outputs, which they're obviously not existing in. Then we're looking at the main amplifier input. Then we're looking further back to the preamplifiers, their input. And if they don't have an input, we look even further back to see where it enters the amplifier circuit, and that's from the tuner circuit, or if we have a guitar, from the guitar's input wire. Of course, there's going to be a small generated the pickups, without any external power, generate their alternating current in the guitar. So there's obviously gonna be seen a small wave on the oscilloscope if you hook it up to the guitar cable, unless there's something wrong with the cable or the guitar itself. So where does it disappear in the circuit? Just look for where the amplifiers, where the chips are, where the outputs and inputs are. Try to look them up. They can be confusing in a diagram like this where exactly they are, but sometimes you get lucky and have large symbols like this. Auxiliary input is here, FM is here. I hope you know what I'm talking about, because I hope you can see the mouse. Here are large symbols of which signals are going in which direction, and phono for our phonograph. So where do the signals disappear? And do an evaluation first. Is it only the radio which is defective? Does the auxiliary and phono work fine, but only the radio is defective? Or does nothing work? Or does only one channel work and one doesn't? If one channel works and one doesn't, in all applications, that means AM, FM, auxiliary input, phonograph, video, guitar, whatsoever, whatever you choose, there's always going to be one dead channel. Well, that's certainly going to imply that you have some sort of complication with your amplifier circuit. If you have a problem with your left channel, there's going to be a problem with your left channel amplifier circuit. It can even be due to dirt in some contact. That's a typical failure. Try to put a lot of contact cleaner in all the contacts and work them around. And if you have no sound whatsoever, there's likely a problem with the supply voltage to the amplifier, which is going to be direct current. If there is only one of the applications that have failed, for example, the phonograph doesn't work, but all the other applications work fine, auxiliary and radio and all that stuff, well, there's probably going to be a problem in the preamplifier for that exact application. But in most cases where there is no sound at all, it's due to a faulty power supply to the amplifier circuit. And that's often the same power supply for both amplifiers, both channel amplifiers. But what's not going to be the same is the input signal, because we have two different sound settings, one left and one right. But the power supply is of course going to be equal, as the strength and setup is equal, totally equivalent of each other. Well, then we typically have only one power supply, but two amplifiers. So if the power supply fails, we're gonna have no power up for the amplifier. And if there's only one channel that works throughout, as I said, throughout all the applications, AM, FM, auxiliary phono, there's gonna be most likely a fault in one of the amplifier's channels, one of the amplifiers on either channel, on the fault channel of course. And if there's gonna be a missing, let's say a missing left channel only when we choose our phonograph, but all the channels work fine with all the other applications, well, it could be a broken wire going from the phono input interface and to your phonograph signal processor, aka preamplifier. One of the two wires could have failed. If you only have the one dead channel with one application, it's very likely going to be a wire or a preamplifier. I hope this makes sense. So as I explained here, think about fluid, think even about water when regarding voltage in relation to current and brakes and how you should search for it. Try to use the given voltages in relation to ground. Search wherever you can for given voltages and look for signals. Do we have signals? Do we remain signals? Where do they disappear? Where do we lose the input? Where in the circuit? Does the wave disappear with the oscilloscope? And where in the circuit? Does the voltage disappear? Where is the break? Where is the faulty component? Or where has a wire broke, or a soldering joint blown? And as I said, try to do the easiest things first. Clean the contacts, check the fuses, have a visual inspection. I hope that this makes sense for you. And if there's anything you would like me to elaborate on, just leave a question in the comments section. Thank you for watching.